Flow element, flow indicating transmitter, flow, or this could be flow transmitter. It depends on if it actually has that digital reading in the field or not, okay? Flow indicating controller, flow transducer, flow control valve, or flow valve. Okay. So in instrumentation, y'all are going to be taught it, maybe not, we might be getting, no, yeah, y'all will be next semester. Y'all are going to be taught it, that class is geared more in the I&E instrumentation field versus operations. Final control element. And that's not on a P90, PFD, any process drawing that you're looking at, it will not be SCE. And the instrumentation stuff that they look at, it will be. So it's what you're controlling, right? But for them, but flow control valve, flow valve, and if it's a level loop, control loop, it'd be what?
Control valve.
It'd be flow control valve that's controlling level.
Level. Flow control level.
Flow control level.
You said
Element.
Level control valve. First letter is going to represent the process variable. Yeah, and if it's controlling pressure, what would it be?
Pressure control.
Pressure control valve. Okay. Good on this? All right, now let's go through and start explaining what is going down. Okay, so we're gonna say, so this element, what the element does is it measures whatever process variable it is, okay? So what is this one measuring?
flow.
First letter. I'm always going to tell you, okay? So there are different elements. There are different types of measuring devices that can measure flow, okay? There are different types, and what measures flow isn't going to measure level, right? But an element is just an overview. If it's an element, it is measuring, right? Whatever the process variable might be. This right here, this is the symbol for an orifice plate. Okay, so did I go over with y'all that this symbol right here, that represents flanges. We know what flanges are, okay? You'll see it randomly throughout your pipe. Now, an orifice plate, flanges are included in the symbol because they go in between two flanges, okay? So with your orifice plate, you will have a flat side and a beveled side, okay? Your pipe or your flanges will sit right up close to where that beveled side starts. And when I pass these around, you'll notice that one side says inlet. So when you have contractors that are just finished a turnaround or something, I'll go over what a turnaround is in a minute, but they're building or adding on or changing or fixing, right? You're gonna wanna go and check and verify the flow direction matches the inlet side. Because they have put them in backwards. Same with your check valves. Check valves have a big arrow on the back side of it. So, okay, so it's not going to be like changing your flow to where it's affecting your process because the flanges don't come all the way out here, right? When it's used as a measuring device. Okay, so your flanges are going to come right up against this beveled side. Your flow is going to go into the flat side. And what it's wanting to create is a difference in pressure on the inlet compared to the outlet. The transmitter is going to have tubing going to the transmitter from both sides of the orifice. So it'd be like right here, and then it'd meet up with the transmitter and it'd convert that, but we're not I&E. So what it's doing is creating a differential pressure. So that could be referred to as a DP, a delta P, or a differential pressure. The symbol for that, again, not something I'm going to test y'all on, but good to know. The triangle, that means delta, differential, different DP, pretty much. So if it's differential pressure, that'd be the symbol. Be a triangle, right? If it's differential temperature, simple. Okay, so what that is actually doing, what delta P or differential or DP means is there's a difference in pressure on the inlet of a piece of equipment compared to the outlet. And so if I have 10 going in on this side and 9 going out on that side, what's my difference? So you have a differential pressure, a delta P of 1. Does that make sense? So we want to create, this creates that delta P. It goes in the flat side so that way it can spray out, because if it's on the beveled side, it's not going to create that dP we need, okay? And we're not INE. We're not instrumentation, right? So we don't really need to know how that conversion happens. How does it use the delta P across this to convert that measurement to flow? We're not INE techs. We don't need to know that. We just need to know how this works, that it's the most common type of flow element. So it is the most common type of device that measures flow. There are different types, so. And what it does is creates a dP and then converts that measurement to flow, okay? But just in general, a flow element is something that measures flow. An orifice plate is the most common type of flow element. Okay. So just, I'm gonna pass it around. Notice how it says inlet on one side of the handle, because that's gonna be out of your flange that you can see, right? And then there's a flat side and a beveled side, and the flow would enter on the flat side. So, FE, it measures flow. Can I erase? So this is on the chart. It says define. So the define is measures flow. Okay. This is your FIT, but I'm going to go ahead and skip that for a second. Okay. So let's assume our FE is from Germany, so he speaks
German.
Yeah. Okay. And our FIC is from France, so he speaks French. Okay, so if we had a French president and a German president and they couldn't speak the other language, what do they need to be able to communicate? Translator. So the transmitter translates the measurement to the FIC. Easy?
Is that what we write on it?
Yep, translates the, that's the definition. And by definition on there, I need to change it probably, but I mean, what does it do?
Can you
Okay,
repeat that?
so
Purpose.
FIT,
Yes,
Transmitter does what again?
translates the measurement to the FIC. So because the element and the controller don't speak the same language.
oh, to the controller.
To the FIC, aka the flow indicating controller, right? Okay, now the controller, I'm gonna explain it and then I'll go ahead and type it real quick for y'all, so that way it'll be easier to write down, okay?
Translate, sour paper.
Yeah, alright, so, y'all have heard people say, or y'all heard me say that the planes are mostly automated now? They don't need the big muscle. Back in the day, you could start off as a shoveler or a concrete man or a ditch digger and end up being an operator. Okay? They need the muscle. Now they need the smarts. Because they have automation for a lot of things. Newer technology, right? Is Brandy's head blocking?
Is it?
Switch to that side, yeah. There you go. Alright, so a movement. I thought a movement. I wear
Yes, I know.
moo-moos. Yeah. Alright. I'd be bringing it. Well, not really. I've switched to my husband's shirts that he stains up and doesn't wear anymore. And then sometimes I just fill his nice ones that aren't stained up because he never had too many oversized t-shirts to wear. Alright. So you have your actual measurement, which is being measured where? Okay, let me go over this real quick. This right here is your actual process. That is the pipe that your process is in, right? The valve is going to be open and closing. This is measuring your process flow, right? All of this is instrumentation. Okay, so this measures your flow. So where your flow element's measuring your flow, that's your actual measurement. That is what is actually flowing through the process, right? So the FIC, he's the big dog, he's calling the shots. He's gonna be, well, your board operator, you say that, we do it like that. So he'll click on this controller. He'll put the controller in auto. And then he'll adjust the SP. SP is set point. It is the desired measurement. Okay? So he's the one that puts in the desired measurement. He types it in. And if the controller's in automatic, it's gonna automatically be doing some stuff, okay? Okay, so it's gonna compare the actual measurement to the desired measurement, and then it's gonna send a command saying, oh, I got 50 gallons a minute, I want 48, right? It's gonna say, hey, well, let's look at that. Flow's going this way, right? If my flow was too low, what would we expect that valve to do? And if my flow was too high, we had too much flow,
Automatically control it.
it's gonna be automatic. So what would the valve automatically do?
Control it.
It's gonna open or close.
Close
It's gonna pinch it back, right?
it.
Make sense?
If it's too much,
You
it'll
looking at me a
close.
little confused. You're not confused? Okay, well, it's okay to be confused. We'll interact so that way I know you're not confused.
Brandon.
I was about to say Brandon. I know that's not it. That's Brant.
Brady.
Brady. We going with the Brady bunch. That'll help me remember that. Okay, so it depends on if this valve is air to open, air to close, right? But this controller's gonna say, hey, bruh, I got too much flow. I need you to pinch back a little bit. Okay? So he's comparing the actual to the desired, then sends a command to the valve, or sends a command to adjust the valve position in order to achieve or maintain the desired measurement. Yeah? 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 Okay. I'll type it real quick. That'd be easier than me trying to write it. I wrote it last time, but this way y'all can actually get the through of it.
And this is all for FIC, right?
Mm-hmm. I have part of it filled in for you. Where'd y'all fill in the blanks at? It's after it compares the, and then it's blanks? Actual. So I could do it like this, because I think it's blank just for actual.
What happened?
I'm refreshing this and putting it on Google Slides so it big. I got editing. Does it say this part? Command to adjust the,
Where?
well, that question's still in blank, right?
Yes, but nothing
Just
was
define.
pre-filled.
Nothing?
No.
It just says
Yeah.
schedule and then define.
Oh, I edited it after I printed y'all. Okay.
Yeah.
Okay, well, then yeah. Then never mind,
So how
I'll
you-
underline all this. Okay, so this is a lot of word jumble. In the future, you'll learn, and by third semester, you'll learn what SPOPPD means on the board, which is OP's valve position, SP is desired measurement, PD is actual measurement. And then that makes this a lot shorter of an explanation, but I'm not gonna add that to the list of things y'all need to learn in this section. So, a lot of words, the test, that's what it is, has to fill in the blank, compares adjust the, we got 5 minutes left of class now. Alright. Okay, so next we got didn't mean to do that. Next we got the transducer. And if I Google to transduce, what that means is to convert something to something else, right? Now what kind of signal based on, you can just stop it. This isn't what I was wanting